Hi there, this is Penelope and this is Chapter 10, Part 1 of FS 2100 that matches the textbook Basic College Mathematics. In this section we're going to look at real numbers. First though, we're going to look at integers. Now we've got, on the one hand, we've got negative integers. And these are the numbers -1, -2, -3, and so on. On the other hand, we've got positive integers. And in the middle, we've got 0, and 0 is neither positive nor negative. So integers to the left of 0 on the number line are called negative integers, and those to the right of 0 are called positive integers. 0 is neither positive nor negative, and it's kind of its own opposite, if you like. So the integers then are -5, -4, ... They don't start at -5, -3, -2, -1, 0, 1, 2, 3, 4, 5, and so on. We can use integers to correspond to various different situations. The first one, Death Valley is 282 feet below sea level. We could write this as -282 feet. Margaret owes 312 on her credit card, so we would say that that was -$312, but she's got 520 in her check account, so we would say that was plus 520. And if we're talking about integers, we probably don't use the units, but that gives you the idea that you can have negative and positive. Fractions are not integers. So we've got integers, and then we've got a bigger set called rational numbers that do contain integers, but they also contain fractions. So a rational number is just one, as you think about the word, it's a thing that's a ratio. So 2/3 is a rational number. -2/3 is a rational number. 7/1. Now that's actually an integer, but we can write it as a rational number because integers, here they are here, they're inside the set of rational numbers. -3 is a rational number. 0 is a rational number. 23/8 is a rational number. 2.4 is a rational number because we could write that as a fraction. We could even write it as just 2.4/1. -0.17. We can turn that into a fraction. It is a rational number. So all it means is that we could write the number as a ratio. Here's the official story that a rational number is any number that we can write as A/B, provided B is not 0, because remember, we can't have a number that's A/0, so we can't have that. So provided B is not 0, any ratio is a rational number. If we're asked to graph a number, it means putting it on a number line. So in this case, find where 7/2 is. 7/2 is the same as 3.5 or 3.5. So it's going to be halfway between 3 and 4. So it's going to be about there. So 7/2 is going to be there. To graph -3.8, now -3.8, it's, think about this, it's 8/10 of the way from -3 to -4. So we need to find -3, -4. There's -3, there's -4. And 8/10 of the way is going to be about there. So we'd say that is -3.8. We've done this before to find a decimal for positive 7/40. But now we're going to find the the decimal notation for negative 7 over 40. So let's start off with 7 over 40. That means 7 divided by 40. So that means 40s into 7. Put some zeros in because it's not going to work. 40s into 7 doesn't go. 40s into 70 goes 1. Subtract. Bring down. 40s into 300 would be 7. 7 40s are 210. Subtract. 7, that's not right. 280. So that's 20. Bring down. 40s into 200 would be 5. And we're done. So 7 over 40 is equal to 0.175, but we didn't have 7 over 40, we had negative 7 over 40, so our answer must be negative. Don't forget the negative sign. We've done the calculation 1 over 12 before, and we know that it means that, but in this case we've got negative, so we need to put in the negative sign. So 1 over 12 we already know is 0.08333 because it's 12s into 1. And we can write that as an approximation like that. So what we've got then is that 1 over 12 equals 0.083 recurring. And now negative 1 over 12 is equal to negative 0.083 recurring. Now we've got the integers. Then we had the rational numbers. Now there's a bigger set around that is the irrational numbers. The numbers that we can't write as ratios, and these 3 circles we call real numbers. You can see this information on a diagram, so that real numbers are split into rational numbers, which we can write as ratios, and irrational numbers that we can't, and a couple of them are pi and some square roots. Then rational numbers are divided into integers and not integers, and integers themselves are divided into positive integers, 0, which is neither, and negative integers. We can use a number line to work out whether numbers are bigger than or less than, and we can use a special symbol. This symbol means less than, so we could read negative 4 is less than 8, and this symbol means is greater than, so we would say that negative 6 is greater than negative 9. So negative 6 is greater than negative 9, and negative 4 is less than 8. We can check this information out on the number line to see whether a number is smaller than or less than, and then we can put the right symbol in the box. Let's have a look at number 1, negative 7 and 3. If we look at it on the number line, negative 7 is to the left of 3, so negative 7 must be less than 3, so we can put less than in there. For the second one, 8 is to the right of negative 3, so we would say that 8 was greater than negative 3 and put greater than in there. And the third example, it's not on the graph, but negative 21 is to the left of negative 9, so negative 21 is less than negative 9, so we'd put less than in the box. We don't have to just deal with whole numbers. If we have a look at negative 7.2 and compare that with negative 5 over 2, so that's about here, and 5 over 2 is about there. So negative 7.2 is to the left of, so it's less than negative 5 over 2. If we look at the second example, whoa, that's going to be a bit hard. 5/8 and 8/13. What we need to do is we need to perhaps say those numbers are a bit close. So we need to find what 5/8 is and find what 8/13 is. And 5/8 would be 0.625 and 8/13 would be 0.6154. So just by a whisker, 5/8 is greater than 8/13. So I can put that symbol in the second one and that symbol in the first one. The absolute value of a number is its distance from 0, and we use two parallel lines to represent the absolute value. So if we're saying the absolute value of negative 3, that means it's 3 units from 0. This does lead to a kind of odd formal definition, so that it says if the number is negative, its absolute value is positive. So if the number is negative, then the absolute value is positive. If the number itself is positive, then its absolute value is the same as that value. So that's just the formal definition. To find the absolute value of negative 5, that's the distance from negative 5 from 0 is 5 units, so that would be 5. The absolute value of 36, it's already positive, so it's 36. The absolute value of negative 52, it's 52 units from 0, so the absolute value is 52. And the absolute value of 0, the distance of 0 from 0 is 0, so the answer is 0. We can use real numbers and the number line to add numbers, but we can also add them obviously without. So let's look at that now. If we're going to use the number line and we're going to add, then if we're adding a positive number, we move to the right. If we're adding a negative number, we move to the left. And if we're adding 0, then we don't do anything, we just stay where we are. To add 3 plus negative 6, it's a negative number, so it means we move to the left. So we start at 3, which is there, and we go 6 units to the left. So 1, 2, 3, 4, 5, 6. By the time we've done 6 units to the left, we are at negative 3. So 3 plus negative 6 is equal to negative 3. Negative 5 plus 8 means we start at negative 5 and then we go 8 units to the right. So 1, 2, 3, 4, 5, 6, 7, 8. And we've ended up at 3. So negative 5 plus 8 equals 3.